I call the mole the ultimate chemical collective noun. A collective noun is a noun that names a collection or aggregate of individuals with a singular form, like assembly, army, jury. Now we know that equal volumes of any two gases will contain equal numbers of molecules if they're measured at the same temperature and pressure. So we can find the mass of a number of molecules by finding the mass of equal volumes of gases, again at the same temperature and pressure. A mole of any element is the number of atoms, the mass of which is the mass given on the periodic table. So for instance, 1 gram of hydrogen, since that's the number on the periodic table, 1 gram of hydrogen is a mole of hydrogen atoms. Now that number is 6.02 times 10 to the 23rd, or in round numbers, 10 to the 24th. It's called Avogadro's number, but Avogadro did not know what that number was. In fact, he didn't even use the term mole. He was the one who determined that equal volumes of gases have the same number of molecules, and that's why we honor him with Avogadro's number, even though he didn't know what it was. Now, this number is only used in tests and special applications. It is really not used on a day-to-day basis by chemists. So let's talk about moles and compare it to another collective noun, dozen. The analogy to the mole is the dozen. Eggs are not sold individually in North America. They're sold by the dozen. Suppliers sell them by the dozen. Retailers will sell them by the dozen, the half dozen, the 1.5 dozen. I've even seen cases of 3 dozen eggs in a retail outlet. And consumers buy them the way they're sold. So, if a question is given in dozens, and the answer is given in dozens, do we really need to know how many eggs are in a dozen? For example, if Mira needs 3 dozen eggs for a big meal, and eggs are $2.50 per dozen, how much will the eggs cost? Well, the cost is equal to 3 dozen times the conversion factor, $2.50 over 1 dozen. Dozen over dozen is 1, and so we're left with $7.50 as the cost. And at no time did this problem require us to know how many eggs are in a dozen. Mole math is similar. If the question is in moles and the answer is desired in moles, do we need to know how many atoms are in a mole? Answer, no. So, if the molecular mass of carbon dioxide is 44 grams, how many moles are in 22 grams? Let's solve the problem. Question mark moles of carbon dioxide equals our given 22 grams times our conversion ratio. 1 mole is 44 grams. Grams over grams is 1, and so the answer is 0.50 moles to 2 significant digits. So your turn. The molar mass of sulfur dioxide is what? Well, sulfur is 32, and there's 2 oxygens in the molecule. 16 times 2 is 32. So 32 for the sulfur, 32 for the oxygen, 64 grams per mole. So how many moles of sulfur dioxide are in 96 grams of sulfur dioxide? You can solve the problem by yourself and then check back over the video to see what the solution is. Moles of sulfur dioxide equals 96 grams, that's our given amount, times the conversion ratio, 1 mole over 64 grams. Grams over grams is 1. Answer, 1.5 moles. So in nearly every case, the number of atoms in a mole will not enter into your calculations. You'll be working with moles of elements in compounds, grams of elements in compounds, and liters of gases. And here is an equation that would be helpful. Number of moles of anything is equal to the number of grams times the ratio 1 mole over the molar mass.